Hi, today's lesson will be about points, lines, and planes. The objective is to understand and use the basic undefined terms and defined terms in geometry that we're going to use throughout the rest of the year. A point is the most fundamental piece of geometry. It represents a location. Points have no length, width, or thickness. To note, the notation for a point is one letter. This would be point A. A line is an infinite set of points that extends in two directions. Lines have length, but no width or thickness. The notation for a line is either one lowercase letter or two capital letters, whichever is shown in the diagram. If we use two capital letters, we do want to use the symbol with two arrows on the top to show that we're talking about a line. In the figure below, is line AC the same thing as line AB? Yes, both of those notations name the same set of points. You can name this line AC, AB, or CB. Can this line be labeled as line ACB? No, we only label lines using two letters, which are points on the line. A plane is an infinite set of points that creates a flat surface that extends without ending. Planes have length and width, but no thickness. The notation for a plane will either be one capital letter or four letters, which create the edges of the plane. Although the plane does not end, we represent those edges with four letters. That will be what we use most often. Space is a set of all points. This creates three dimensions. Few questions. How many points does it take to make a line? Lines are made up of at least 2 points. How many points does it take to make a plane? All planes require at least 3 points that are not on the same line. And how many points does it take to make space? Space is at least 4 points not all on the same plane. In many of our diagrams, just because something isn't drawn doesn't mean it isn't there. For this example, we have 3 points, L, M, and N. We can draw lines LM, LN, and MN into this diagram. They weren't there originally, but if you can draw them there, they do exist. The next term we're going to look at is collinear points. Collinear points are points that are on the same line. In this example, we want to name 3 collinear points. Those are the 3 points that are already on the line, which are A, C, and B. If we want to name 3 non-collinear points, we could use A, C, and X. Those 3 points cannot be drawn on one straight line. Coplanar points are points that are on the same plane. What point is coplanar to points A, E, and G? That would be point B. A, E, G, and B form the top side of the prism. What point is not coplanar to points A, E, and G? There are many different answers for this one, but we could use H. Points A, E, G, and H will not ever all be on the same plane. Name 4 coplanar points. There are many different answers for this one. You could use BGHD, HGHD, CF, CAEF, and there are many more. Name 4 non-coplanar points. Again, there are multiple answers. You could do A, E, F, and D, B, G, H, and C, And there are many more. How many planes are in the figure above? Here's a list of all of the planes. The first 6 are the sides of the prism. The rest are planes that you can draw in that are diagonal planes. For example, A, B, H, F starts at the front of the box and goes diagonally to the bottom of the back of the box. Our next topic is intersection. Intersection is the set of points in 2 or more figures. The first intersection we'll look at is when 2 lines intersect. They're always going to intersect in just one point. That point is contained in both of the lines. A line and a plane intersect in one point as well. You can envision a string going through a sheet of paper. It's only going to intersect the paper at one point. We can also talk about the intersection of planes. 2 planes intersect in a line. Both of these planes contain all of the points on the black line. 3 planes intersect in a point. The point in the middle is the only point that is contained in all 3 planes. Take a look around. What objects in the classroom or wherever you are represent a point, a line, and a plane?